Hello, math magicians. Here are your notes for lesson 4.3. We are still solving systems of linear equations. To solve means to find the solution, and a solution is a value or values that make an equation true. So we're looking for the values when substituted back into an equation, actually make it work, make it true. And it's systems, and remember, systems tells you that you have two or more equations. And the types of equations we're still dealing with are linear equations. Linear equations, when you graph them, you will end up graphing lines. Okay? And so they would be of the form either slope-intercept form, y equals mx plus b, or they might be in standard form, ax plus by equals c. So when we solve, we're trying to find the point where these two or more lines will intersect. So we're looking for a point of intersection. The first method we learned was graphing. Graphing is a great tool for visual aid. It's a great visual aid. It's rather tedious, and sometimes it's not always accurate. Then we learned the substitution method. It is always accurate. You can always find the exact point of intersection, but it also is a little tedious. So today we're going to learn a third method, which is my favorite, and the third method is elimination. Alright, so let's go through an example, or two, or three. So here's example 1. Let's say you have 3x plus y equals 11, and you have 6x plus 3y, and that's going to equal 24. Okay, here I have 1, 2, so I have two equations. That makes it a system. And both of these are linear. If I did take the time to graph either this one or this one, they would form lines, and they would intersect probably. And our job is to find the point of intersection. Right, this one's in standard form, this one's in standard form, but I'm not going to graph them. I'm going to use elimination. So with elimination, what you want to try to do is notice how I have the x's lined up and the y's lined up and the constants lined up. So that's the first thing. Then what you want to try to do is get either the x terms or the y terms to be opposites of each other. Okay? So I either want the x's to be opposites or the y's to be opposites. So I have a choice, and there's not a right or a wrong answer. But what I'm going to do is I'm going to make the y's become opposites. And I'm going to do that. I want this to be, since this is 3y, I want this to become negative 3y. So to do that, I'm going to multiply this entire equation by negative 3. Alright, so the entire equation, all terms, everywhere, on both sides of the equal sign. Alright, and that's going to give me, what will that give me? Let's see here. Negative 3, that's negative 9x. And then negative 3 times y is negative 3y. And then negative 3 times 11 is negative 33. Okay? Now the bottom equation, I'm just going to bring that right over. Just rewrite it. Keep everything lined up, like terms lined up. And now what I'm going to do is add. Okay? I'm going to add. So what I did is I multiplied every term, 1, 2, 3, every single term by negative 3 on both sides of the equal sign. And I did that so these would be opposites. Now I could have made the x's opposites, but I chose to make the y's opposites. Now I add. So you just add like terms. Negative 9x plus 6x is negative 3x. Negative 3y plus 3y, that's eliminated. Elimination method. That's eliminated. And then negative 33 plus 24 is negative 9. Now continue and solve for the variable that you still have. So the y's were eliminated because they were opposites, and when you add opposites you get 0. Now solve for the other variable. So I'm going to divide both sides by negative 3, and you get x equals 3. Now all you have to do is take that value, x equals 3, and plug it back in to either one of the original equations. It doesn't matter. You can plug it into the first one or the second one. But I would plug it back into one of the originals. This first one looks a little easier to me, so I'm going to write 3x plus y equals 11. And I'm going to take this value and substitute it right in this case for the x, because x equals 3. So x is going to turn into 3. So I'm going to have 3 times 3 plus y equals 1. Well, 3 times 3 is 9 plus y equals 1. And then just subtract 9 from both sides. Y will equal, if I subtract 9 from both sides, whoops, that's not 1, is it? That's not supposed to be 1, that's supposed to be 11. So I can fix that. 11, 11, 11. And now, like I said, subtract 9 from both sides. 11 minus 9 is 2. So I have my solution. In my solution, I'm going to put as an ordered pair. And remember, x always comes before y in an ordered pair. So my solution, x is 3 and y is 2. And that is the point of intersection. Now you could double check to make sure you're right. You could take these two values and substitute it into the other equation, the one I didn't use. So quickly, 6 times 3, right, because x is 3. 6 times 3 is 18. 3 times 2, because y was 2. 3 times 2 is 6. And 18 plus 6, yep, 24. So it works in the first equation and in the second equation, which makes it our solution, which is our point of intersection. All right, so there's the elimination method. All right, let's try another one. Okay, the second equation, or second example, number 2, 3x minus 4y equals 33, and 4x plus 3y equals 19. Okay, elimination method. Line the like terms up, x's, y's, and constants. So make sure your like terms are lined up. And decide, it doesn't matter, do you want the x's to become opposites or the y's? And it doesn't matter. I guess in this one, just for variety, let's make the x's become opposites. All right? So let's see. I need to change these both I have to change them both this time. 3 and 4 can both go into 12. So I'm going to multiply the top equation by 4. So that means distribute this 4 to every single term. Every term. Most common mistake kids make, they forget to multiply it to every term. 1, 2, 3. All right, what's that going to give me? All right, 4 times 3x. 4 times 3x is 12x. 4 times negative 4y, negative 16y. And then 4 times 33, just a second here. I believe that will give me 132. Okay, so I just turned that into a 12x, so I need to turn the other one into a negative 12x. You want them to be opposites. So to turn this into a negative 12x, I'm going to have to multiply everything by negative 3. So again, distribute every term, both sides of the equal sign. All right, what will that give me? Negative 3 times 4x, negative 12x. Negative 3 times positive 3y, negative 9y. And then negative 3 times 19, I believe that would be negative 57. Okay. So, I have the x's being opposites. It doesn't matter x's or y's, doesn't matter, but I chose x's this time. So now you add. All right, what is 12x minus 12x? 12x minus 12, that's eliminated. This is called the elimination method. So always one of them gets eliminated, one of the variables, and it's the one you made opposites. All right, negative 16 minus 9, negative 16 minus 9, I believe that would be negative 25y equals, let's see here, 132 minus 57, I believe that's 75. Now continue solving for this other variable. I'm going to divide both sides by negative 25. And I figured out that y is negative 3. All right, great. I have one of the coordinates. Now you're going to take that value, y equals negative 3, and you're going to plug it back into either the first or the second, doesn't matter which one, of the original problem. So I think it really doesn't matter. I'll take the first one. So I'm going to rewrite the first one. 3x minus 4y equals 33. But remember, I'm going to take this value and plug it in for y this time, right? Because this is y. So it takes the place, it substitutes in for y. So 3x minus 4 times y, but we just figured out y is negative 3, equals 33. So 3x, let's see here, a negative 4 and a negative 3, when you multiply a negative times a negative, would be a positive 12, equals 33. Subtracting 12 from both sides, that would give you 21. And then divide both sides by 3, the x coordinate would be 7. So my solution is, remember, x comes first, then y. So my solution would be 7, comma, negative 3. And that would be the point of intersection. All right? If I did take the time to graph this line and graph this line, they would intersect at this point, 7, negative 3. And if you wanted, you could take these two values, plug it into the second equation, and make sure it actually works. We already know it works in the first one. Check it on the second one. All right, I hope this is helpful, and good luck.